So what we're going to have a look at today is this idea of distribution. Okay, now, firstly, before we even start stressing about these examples, we need to remember and we need to go back to what distribution is. So distribution often happens when we have brackets, and what distribution means is we need to multiply. So I always think of distribution like fireworks. If we look at this first example, this coefficient of 4 needs to be multiplied by both the 2x and the -1. So I almost imagine it as fireworks going into my bracket, distributing that 4 to the values or the terms inside my bracket. All right, so basically that is distribution. Very importantly is that you need to remember that it is the operation of multiplication. That is what we are doing when we distribute. And as I've sort of said quite a few times already in this course, what we always need to be mindful of is bodmas or bedmas. I don't really mind which one you choose to use. It doesn't really matter. And the second we now start paying more attention to bodmas or bedmas, what we can see is that distribution now comes into essentially brackets, but mostly into this division multiplication section. And so we have to do distribution first before we even start thinking about finding like terms and so on, like we have discussed previously. So if we have a look at this first example, the first thing I need to take note of, guys, is the fact that I have got two separate terms here. So just another quick reminder, terms of an expression, they are like the parts or the words that make up this mathematical sentence. They are separated by plus and minus signs. And so what that means is, and we ignore the signs in the brackets, just in case you don't remember it. So ignore signs inside the brackets. And so what that means is if we're ignoring, whoopsie daisies, if we're ignoring this minus and this minus, I have got one negative sign in this expression that is allowing or that is creating a separation between terms. So here I've got my first term of 4 times the bracket 2x minus 1. And here I've got my second term of minus x times x minus 1. Now, this is very, very important that we identify our terms before we just start distributing, because remember, we need to make sure that we are multiplying the correct values by the coefficient. We can't just times everything by 4, because not everything needs to have the 4 distributed to it. And so we need to be very, very careful of where our terms are. And this is why we've This is why we've talked and spoken so much about how to identify terms, what are terms, what are like terms, etc., etc., so that when we start to build in complexity, we understand what we're doing. Right, so the first one's relatively easy. What I just want to remind you about our second term is please remember that we do have a coefficient of -1 here. We don't write the 1 in, we can just write the minus sign, but there is actually a coefficient of -1. And what that means is in or when I start to do the distribution, I'm going to distribute, or I'm going to multiply -1 to the x term and -1 to the -1 term. So my distribution needs to take into account the fact that I've got 2 terms, each of them with a different coefficient that I need to multiply in. So if we have a look at our first term, the first distribution, we have got 4 times 2x and 4 times -1. Now, guys, remember, if you need to do a little section of working out for yourself, by all means do that. 4 times positive 2x, a positive times a positive is a positive. 4 times 2 is 8. And then we've still got the x there. And then we've got 4 times -1. A positive times a negative is a negative, and 4 times 1 is 4. So when I distribute this first term, I end up with 8x minus 4. So that's all from my first term. I then need to go ahead and distribute my second term. So my second term's distribution, let me just made the square very weird length, but anyways, we'll just pretend I made it a normal usable length. Our second distribution is then this -1. So we've got -1 times positive x. I'm writing another bracket, but anyways. A positive times a negative is a negative. Remember, this x does have a coefficient of 1 as well. 1 times 1 is 1. And then we've got our x. So we have a -1x. You don't have to write the 1 if you don't want to. It's completely up to you. And then our last distribution is -1 times -1. A negative times a negative is a positive, and 1 times 1 is 1. So we've got +1. Once we have distributed, this is now where we start adding and subtracting like terms. So I'm going to make a little note here. Once we have distributed, we can add and subtract like terms. Right, while I'm writing this out, can someone on the chat tell me or remind us what like terms are? Someone on the chat. I don't want any hands. I just want it typed out on the chat. Sibonga, nice. I want you to try and expand a little bit on that a bit more. Good, English, Lawazine, good, nice, guys. Okay, so like terms are terms that have the same variable and the same exponent. So if I just have a quick jump back to our last lesson, and of course everything's all over the place, and so it's going to confuse me. If we jump back to our like terms that we spoke about last week, Wednesday, this was the definition that we wrote down. The fact that like terms have the same variables and the same exponents. So if you don't remember that, you need to go and watch that video. But this is now essentially what we need to take into account when we start to simplify this expression. So my like terms, this is now, guys, where I always say grab a highlighter or grab like a colored pen or whatever you want to do, and let's start highlighting our like terms. So we're looking for same variables, same exponent. So here I see I've got an x term, and maybe let's make this highlighter a touch bigger. Guys, I'm not going back to the definition of like terms. I have already done that. That was in last week's lesson. You need to go and watch the video in order to get that if you didn't write it down. All right, so 8x is a like term with -1x. So those are going to be some of the terms I'm going to add together. And then completely separately, I've got -4 plus 1. So those are my constant terms. Now, remember, I've said to you, if you want to put the like terms together, because that makes your life easier, by all means, you're welcome to do that. And so what we can now do is we can add and subtract our like terms. So 8x minus 1x simplifies to 7x, and -4 plus 1 simplifies to -3. And so what I've done is I've simplified my expression after I have distributed. And so my final simplified expression is 7x minus 3. Now, very importantly here, we cannot add these terms because they are not like terms. Oh, so much information. They are not like terms. So remember, grade 8, you may only add and subtract terms if they are like terms. So if they have the same variable and the same exponent, as most of you put there on the chat as a definition for like terms. Alrighty, just quickly, there was a question of how did I get the 1 in between the brackets? So Reese, I'm assuming you are talking about this 1 over here. That 1, remember, is invisible. It's like the invisible coefficient in front of an x. When I've just got a minus or a plus sign in front of my bracket, there is actually a 1 there. I just don't have to write it down. So it's that invisible coefficient of 1. Right, so guys, take your screenshots of this. I know this was a lot of information. So while you're taking screenshots, if anyone has any questions, now is the time to raise your hand. Otherwise, we will have a look at another example. Kelsey?
Ma'am, how do we take, when they're asking the question, how do we know if it's a minus or a plus in front to, let's say, 8x minus 1x? How do we know it's a minus?
So are you talking specifically over here in terms of how did I know this was a minus?
Yes, ma'am.
Okay, so I know that was a minus because when I did my distribution, and let me just take this purple off. When I did my distribution of -1 times positive x, which is happening over here in the bracket, a negative times a positive is a negative, and 1 times x is x. So that's how I knew that was going to be a negative, because I multiplied a positive and a negative together, giving me a final negative sign.
Thank you, ma'am.
Pleasure. Right, grade 8. I'm hoping we've all taken our screenshots. Right, so this is still just like basic algebra. We haven't even started to think about exponents just yet, but we do need to be able to deal with exponents. So this is very much similar to what we did in our first algebra course. So again, if you're feeling a bit confused or a bit overwhelmed, you need to go back and watch that. But now we're going to have a look at including exponents. So Malezi, in terms of why is it not -1x minus 1? Because a -1 times a -1 is a positive 1. So it's -1x plus 1. We need to be very careful of our signs. Alrighty, guys. So if we now have a look at question B, and you all should have taken screenshots. So if you didn't, again, you need to go watch the recording. What we see is that our multiplication looks a little bit different. Okay, so now if I look at this, remember, if I want to identify terms, I look at only the plus and minus signs outside my bracket. Outside my bracket, I don't have any plus or minus terms. So this is actually just one term that I'm working with. Nice and simple to start off with. So this is now where I am actually going to have a multiplication block, because this is going to be very important that we understand why we are getting the values that we're getting when we multiply. So this is just my working out. Obviously, you are welcome to do a little working out block for yourself. But again, it's important to understand why we are getting what we are getting. Okay, I've been told I'm being too fast. Reminder, this has already been done. And so if you don't know what's going on, you need to go and watch the videos. I'm going back to question A for anyone to take a screenshot, but I'm waiting here for 10 seconds and then I'm moving on. So again, this first question has been covered. This is not new work. And so if you don't know what's going on, that is your responsibility to catch it up, please. Right. So if we have a look at question B, we know that we have one term here. We know that we are distributing. So we know that we need to take this coefficient 4x and we need to multiply it to the x squared, and we need to multiply it to the -2y. That is what distribution is. So if we take this multiplication that we need to do, and we do it in our working out block, the first multiplication is 4x multiplied by x squared. Now, guys, this is where our exponent rules are very, very important to remember. Remember, when you start to multiply variables, we need to remember our exponent rule. So our exponent rule tells us that when we have the same bases, so let's say x squared times x cubed, when these bases are identical, our first law of exponents tells us that to multiply this, we can add the exponents. And so this would give me x to the power 5. So I need to be able to take this exponent law and I need to be able to apply it to my distribution. Now remember, a variable by itself has an exponent of 1. And also remember that this x squared does have that invisible coefficient of 1 in front of it. So when we multiply, we have got a positive times a positive, which is a positive, 4 times 1, which is 4. And then according or applying my exponent law, x times x squared gives me x cubed. How did I get x cubed? I applied my exponent law and I added together the two exponents of the base x's. So when we distribute, please always double check if you need to be applying your exponent laws. Right, before I do the next distribution, there was a question about how to screenshot. Sonwabise, I would definitely agree with you, Linda. The easiest option is to just take pictures on your phone. To screenshot on a laptop is a little bit complicated. You would have to push print screen, and then you would still have to paste that somewhere. So it's much easier to just take a photo on your phone, and then you can go back into your camera roll. So grade 8, so that is my first distribution. So this first distribution over here, where we have gone and said 4x times x squared has given us a product of 4x cubed. I still need to find my next product. So the next product or the next multiplication is 4x times negative 2y. And so what we now need to do is we need to follow the same steps. A positive times a negative. Please let's focus. We've answered the screenshot issue. I appreciate all the help, but let's focus. A positive times a negative is a negative. 4 times 2 is 8. And now be very careful. X and y are different bases. So we can't apply our exponent law here. And so when we multiply x times y, we actually just end up with xy. So x times y. So when you multiply two different variables, you actually just write them out exactly as they are. So this is negative 8xy. So that is my second product when I multiply in my 4x. Remember, we always double check to see if I have like terms. What we notice, hopefully, is that these are not like terms. So therefore, we cannot subtract them. And so this means that this is my final simplified answer. I can't do anything more with that. That is where I stop. Mhlali, y stands for an unknown. It's like x. They are variables. So anytime you have a letter x, y, a, m, p, whatever, it represents a value that you do not know. So y could be a value of 2 or 7 or 28. It could be anything. We don't know its value. So a variable, excuse me, represents an unknown value. Right, so you're taking screenshots. If you have any questions, now is the time to ask. Gabrielle?
Hi, ma'am. Ma'am, I wanted to ask, how did we get -8?
Okay, so the minus 8 came from the distribution. So if I just grab a highlighter here, apparently not. Let me try that again. Okay, so this came from the distribution. You are saying 4 times -2. So this is the multiplication that we're talking about over here. Positive 4 times -2 gives us -8. So it's by multiplying those coefficients together, I'm able to get -8. Does that make a bit more sense?
Yes, it does. Thank you, ma'am.
Good. Okay, Gabrielle, I've asked you to unmute again. You can just ignore me. I'm clearly just clicking a whole bunch of things. Kelsey?
Ma'am, how do you like get the x cube at the beginning?
Okay, so guys, remember the x cubed has come from my exponent laws. So if we go to that beginning distribution over there, we have got an x times x squared. And according to my exponent laws, I add the exponents. So 1 plus 2 gives me that x cubed. And that's how I get my exponent for x. Make a bit more sense?
Okay. Thank you, ma'am.
Good. Okay, just quickly, so Nobise, if we didn't have the bracket, would the method still work? I'm assuming when you say in the brackets, you mean the original bracket from the question. You would have to have something there because you can't have 4x and x squared just sitting randomly next to each other. There would have to be some sort of operation. And usually if it's distribution, it is that bracket. If you were talking about the bracket over here in the distribution step for the 4x times, if you're talking about this bracket over here, yes, as long as you remember to say positive times negative gives you a negative answer. Adlakhan?
Ma'am,
Yes.
ma'am, where did the one come from?
The one in purple that I've written next to the blue x squared.
Yes, ma'am.
So remember, in front of any variable that's by itself, we have an invisible coefficient of 1.
Yes, ma'am.
Okay, so guys, always remember that when you have a variable with no number in front of it, there is actually a 1 there. We just don't have to write it down. Lixa?
Sorry, ma'am, could I please ask, why can't you add the x and the times in x? Yeah.
Okay, say that again. Sorry, you lagged. Why can't you?
So, ma'am, why can't you add the x and multiplying x at the same time, ma'am?
Yolanda, can you hear what the question is? Because I'm struggling.
Please repeat it, Lixa.
Let's try one more time,
Okay,
Lixa.
Okay. Could I please ask, ma'am, why can't you add the variable x to the multiplying x?
Yeah.
The variable x to the multiply x. Why?
Emma.
So are you trying to say you want to take that and that, the multiplication sign?
Yes, ma'am.
Remember, that's an operation. X variable and X multiplication are two different things. So that's telling me what to do. The X represents an unknown. So there are two different types of X's.
Okay, ma'am, thank you.
Okay. Alrighty, so guys, hopefully that's answered any and all questions that you may or may not have had. We are going to have a look at this one, but I'm going to just change it slightly because right, so let's have a look at C. I'm going to give you 2 minutes to try C. See if you can manage to even get somewhere with this. The only hint I'm going to give you is that we need to distribute. And so we need to take this negative 2x and multiply it to the negative 3x, to the negative 6y, and to the positive 4x. So give it a try. Put your answers in the chat once or if you get one, and then we will have a look in about 2 minutes at what the answer should be.
I think Samuel can't see, so maybe we might want to just.
I will reshare my screen now.
Yes, please. Thank you. Samuel, this might sort out your problems. Everyone else, we are trying what we already wrote down. So let's give it a try. Remember, you are writing it on your book until you find a final answer. Then you can share it on the chat with us. Let's go, guys. Give it a try. Everyone else, we are all giving it a try, okay?
Right, grade 8, please. Excuse me. Can I also just remind you that we focus on the topic at hand in this lesson? If you have questions based on something else that is not for this lesson time, you need to go and either find videos on those topics, especially if we have done them, or as Yolanda has told you many a time, please join the class 5 minutes early and ask your question then. Oops.
Remember, my pebs, remember that every single one of you who have tried it, you have put it on the chart, but it's also written on your books. And then teacher Sam will do corrections with all of us, right? You make sure that you correct your work. You make sure that you find out where you went wrong. And if you can't, please, you will let us know after the corrections, then you can put your questions, okay? But you must listen as she's explaining how did we arrive to the answer, okay? Because we're getting a lot of different answers. Then it's best if teacher Sam explains to us how did we arrive to the final answer, okay, my peps? But well done, guys. I love the trying. I love the effort. Y'all are doing well.
Alrighty, guys. Please also, let's just actually, you know what? Okay. I'll deal with it if I need to deal with it. Right, let us do our multiplication. So I told you that there are 3 multiplications that you need to do. So our first one is going to be minus 2x times the first term in our bracket, which is minus 3x. So double check your signs. A negative times a negative is a positive. 2 times 3 is 6. And guys, remember, we've just spoken about this. When you are multiplying variables with the same bases, so x times x, you would add their exponents and you would get a product of x squared. Okay, so negative 2x times negative 3x is positive 6x squared. So that is our first product. We can write that down so long. And then we go to our second multiplication. Our second multiplication is minus 2x times negative 6y. So again, a negative times a negative is a positive. 2 times 6 is 12. And as we discussed in the last question, when you've got 2 different variables, x times y, it is just xy. So we've got plus 12xy. And then we go to our third product, which is minus 2x times positive 4x now. A negative times a positive is a negative. 2 times 4 is 8. And as we already discussed in the first product, x times x is x squared. So we have got minus 8x squared. Now, guys, hopefully what you can see is that the 6x squared and the negative 8x squared are like terms. And so what that means is I can go and add or subtract our like terms. So if I just write this with my like terms next to each other to make my life a bit easier, I've got 6x squared minus 8x squared plus 12xy. 6x squared. Now, guys, let's just go to our number line here, because I know that we struggle with this idea sometimes, and that's absolutely fine. But at some point, you do need to start being more comfortable with this. I can only draw a number line for so long. So if we go to our number line, we are currently sitting at positive 6x squared. I'm taking away 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. That takes me to negative 2. So I end up with negative 2x squared plus 12xy. These are not like terms. And so that means that that is as far as I can go. I cannot do any more than that. So I want you to just take a second, like Yolanda was saying earlier, as we do these and as I do these, you need to be correcting your work as you go along. And you need to be making sure that any mistakes that you've made, you understand where that mistake came from. And if you don't understand, you need to make sure you are asking. So on that note, at this point, if anyone has any questions, you are welcome to raise your hand now. Tredan, I don't think that's how you say it. Please correct me. Traden, I don't know if that's better. Okay, Botale?
Hi, ma'am.
Hi.
Ma'am, so for the exponents, ma'am, it's to the power of 1, right? So, ma'am, we added them, ma'am. So, ma'am, how come 12xy doesn't have an exponent?
So they do have exponents. So both the x and y have exponents of 1, but remember they are different. This is an x and that's a y. So because they are different bases, I cannot add them. If I go back up here, it is only when my bases are the same can I add the exponents. All right, so guys, that's very important. It is only if your bases are the same can you add your exponents. Keisha?
Ma'am, can you hear me?
Yes.
Ma'am, since you said you can add the exponents of the same base, why don't we add x to the power of 2 to x to the power of 2?
Okay, sorry, say that again for me.
Ma'am, since you said we add the exponents of the same base, why don't we add x to the power of 2 to x to the power of 2 to get x to the power of 4?
Okay, so you're talking about over here in the 6x squared and the minus 8x squared.
Yes, ma'am.
Right, remember, we only add the exponents if we are multiplying. It is a multiplication rule. There, you are adding and subtracting. So remember, the exponents do not change when we add or subtract like terms. So let's add that in as a little note. Exponents don't change when we add or subtract. Make more sense?
Yes, ma'am. Thank you, ma'am.
Good question. Okay, so guys, that's also very important. Exponents do not change when we add and subtract like terms. Zanera? You there?
Hello?
Yes?
Can you hear me?
Yeah.
Okay. Is it always possible to switch the two numbers like 8 and 12? It's switched.
Oh, okay. So all I did was I took the like terms that were initially separated and I brought them together. you are welcome to do that as long as you keep the signs correct. So what I mean by that is it was a negative 8x squared. If you rearrange it, it has to stay negative 8x squared. But yes, you are welcome to switch your terms.
Okay, thank you, ma'am.
Sure. Guys, just quickly on the chat, there was a question of how did we get negative 2 on the number line? You've got 6x squared and you're subtracting 8. So that's where we get negative 2 from. Kelsey?
Ma'am, how did you like get 6x squared when in the workup block when it said negative 2x times negative 3x?
So a negative times a negative is a positive, and 2 times 3 is 6. So that's where I'm getting positive 6. And then the x times the x gave me the x squared.
Okay, thank you, ma'am.